Okay, this video is on the growth rate assumption. We're back here to the multiple regression page. As you recall, we used a normalized margin of 8.7%, which is the midpoint between the mean and the median operating margin of the samples, 411 in the sample. If we increase this margin by, let's say, 0.5% to 9.2 or down by 0.5%, the net effect on the nominal cost of capital here is around 0.4%. So within a reason, there's very little effect. As you increase the operating margin assumption, the profits go up, but the value multiple goes up. So the price to earnings ratio doesn't change by much. So we have that. Now, the importance of this, though, is if we know the normalized margin and it's normalized, then the rate of profit growth or free cash flow growth will equal the rate of revenue growth if margins are constant. So that's the importance of normalizing the margins. So assuming we have a normalized margin here, which again is not very sensitive, we can go to our other page and use our 3.5% growth assumption, which means that if revenue is growing at 3.5%, then profits will be growing at 3.5%. Free cash flow will be growing at 3.5%. So, as you can see here, the nominal total cost of capital is the real rate in the Gordon model plus the growth rate. Okay? So, 3.5%. If we change this, how important is this assumption? If we change this, watch this. Copy this. Paste values. Change this to 4.5%. If you change this growth rate from 3.5% to 4.5%, it has a small impact on our conclusion. As you'll see later, this is an extremely large change compared to what we know about what the total revenue growth rate ought to be. Okay, so 3.5%, where do we get that? Let's go to the growth rate. Okay, here what we've done here is we said, okay, once again, we're trying to estimate revenue growth because if we know that margins are constant, we know that profit growth will be the same. So what is revenue growth? Revenue growth over the 15-year period that we're sampling our companies should equal the nominal GDP within the United States. So obviously revenue of all things grows by the nominal GDP. So we think that's no different for small companies. It should be the same. Yet there's going to be additions to small companies, and we assume those additions are pro rata on a per capita basis. So what we're doing here is we're taking the total nominal GDP over the period of time and decreasing it by the number of employed people and coming up with 3.43% on that basis. We also use a productivity method, which comes up with 3.8%. And so looking at the two, we conclude at 3.5%. And that is what goes back here in the model, which is the growth rate. As you can see, it's not that sensitive to a reasonable, within reason, of what people use as growth rates. 3.5% is consistent with people's terminal value growth rates. I've seen as high as 4 and as low as 3. So, oh, yes. Why does this not add a full, let's see, if we go up to 4.5%, why doesn't it add a full percent? The answer is it's not that sensitive because when you increase the growth rate assumption, the amount of book capital grows. See this, 83,000. So growth rate doesn't really affect it that much, because when you change growth, the free cash flow goes down when you increase growth. So watch this. It was 83. Let's lower it to 3.5. Goes down to 65. So there's this offset that really minimizes the change to the cost of capital given changes in growth rate assumptions. And there you have it.